Alright guys, we have 5.3/5.5 lessons with inequalities in one triangle. You guys were supposed to go on to the GeoGebra website and plug in these numbers and figure out whether yes or no we had a triangle or not. Well, just to kind of fill in a few so we can kind of compare. The first one was a yes, the next two were no's, and then we'll fill in this bottom at the bottom is the yes. There's a reason I'm choosing these. The first one here, number 2 discussion question, said look at the measurements that did form a triangle. So if we look at the measurements of sides of 2, 3, and 4, small being 2, medium being 3, large being 4, we ended up with a triangle. Down here we had the 2, 7, and 8. Also gave us a triangle. I was really happy to see some students figure out on their own that what's happening here is when you take the small side and you add the medium side, it's going to end up being greater than the large side. So 2 plus 3 is 5. It's greater than 4, so we had a triangle. When we looked at the ones that did not, one of them here, we had 2 and 3 and then 5. But when you added your small plus your medium, it ended up equaling the large. So this is going to be one that does not form a triangle. The one underneath has 2 plus 3, which is 5, and that's less than the larger side. So if you have small plus medium is less than the large, we do not have triangles. Okay? So our big number 4 says write a rule. This is our rule. Okay? So if you want to rewrite it under number 4, you can, but I just had my kids write that. So this is your rule that you follow. Number 5 is asking, is it possible to have the sum of the small and medium equal to the largest, and asks to explain? The answer is no, and basically our explanation's right here. We found out that it did not form a triangle. I had all my students do the next problem on their own, gave them some time. What we're doing here is deciding if it is a triangle or not, and if so, classifying it. So we're going to take our small and our medium here, 8 plus 9. We're going to get 17. Compare that to the larger side. The sum is greater than the larger side, so yes, we have a triangle. All 3 numbers are different, so we have our scaling triangle, because it's classified by sides. On B, take our 2 smallest numbers, in this case it's the same number, add them together, we get 2. Compare it to that larger side, we find that it's equal. Well, according to number 3 up top and number 5, we realize that if they're equal, no, we do not have a triangle. We don't have a triangle, we can't classify it. How do we classify a triangle if it's not even there? C, we take our 6 plus 6 and we get our 12. We compare that to our longest side of 10, and we add that the sum is greater. This follows our rule, so yes, we have a triangle. And if we notice, we have 2 numbers that are exactly the same. We have 2 sides that are congruent, so we have isosceles triangle. On D, same thing. 3 plus 5 is going to give you 8. Let's compare that to the larger side. It's less than. Does not follow our rule. We do not have a triangle and no classification. Last, well, we don't have a small and a medium, so just grab 2 of them since they're all the same. Add together, we're going to get 8. Compare it to that third side, it is going to be greater. So yes, we have a triangle. So how do we classify it? Well, all 3 numbers are the same. All 3 sides are congruent. We have an equilateral. Anytime that I give you 3 lengths that are exactly the same, you will have a triangle, and it will be an equilateral. Your triangle inequality theorem lets you know that the sum of any 2 sides has to be greater than the length of the third side in order to have a triangle. On the academic level, I'm just telling students to remember small plus medium has to be greater than large. Okay? So, excuse me, number 1, A and B, same exact thing as we've been doing. We're going to take our 2 small and our medium, add those together, we're going to get 23. Compared to 17. Is the small plus medium larger or greater than the large? Yep, we have a triangle. Letter B, we have 6 and 14. Add those together, we get, 6 and 8, I already gave you 14. Compared to our other longest side, these are equal. So no, we do not have a triangle. And it wants us to explain why. Well, easy explanation. Because your small plus medium equaled the large, and we can't have that. Number 2, with the basis of the theorem, is more of what I would consider a KAP question. So with my academic classes, all I did was we talked about here looking at if 5 and 7, these two lengths, were small and medium. We, instead of saying what's the possible length of the third side, we looked at what was the possible length of the longest side. Makes it less complicated. So here, if we add these two together, 5 plus 7, we're going to get 12. So according to our theorem, if a sum of our two smallest, that number has to be greater than our largest side. So our largest or longest side, we know, has to be less than 12. Okay, that's the rule. It has to be less than. But if we take a look at, let's say that our third side, we had 5, 7, and 7. Well, here, we're not adding the two 7s. If we add the 5 and the 7 together, we're going to get that 12. We compare it to that third side 7. It's still going to be greater than, which means 7 can be our third side. Even though we have a 7 here, we can have an additional 7. So it can be equal to 7, but it cannot be less than. Again, we're looking at the longest side. The reason it cannot be less than 7 is because then it's no longer the longest side. So we would say that our largest side has to be greater than or equal to 7, but less than 12. And that's how you read this section right here. The next part is your triangle longer side theorem and your triangle larger angle theorem. This is just telling you if you have a side that's longer than another on a triangle, the angle opposite of the longer side is going to be the larger angle. Same thing with the angles. If we have an angle that's larger, then the side opposite of the larger angle is longer. This may sound confusing, but it's all going to make sense here in a moment because we're going to write something at the bottom. So let's label our angles for number 3. Angle A, 120 degrees. B, 40 degrees. C, 20 degrees. We want to find our longest side. Well, according to the theorem, the longest side was across from the largest angle. So find our largest angle. Angle A over here, 120 degrees. Go across to the other side. This is going to be our longest side. So we could say segment BC or segment CB. Now we want the shortest side. So just the opposite. Our shortest side is going to be across from our smallest angle. So find the smallest angle, C, 20 degrees. Go across. This is going to be our smallest side, segment AB. All right. Next, we want to classify. We see 3 different sides. Okay, 3 different measurements. This is our scalene. Now we're going to order smallest to largest. We want to make sure we go smallest to largest, not the opposite direction. On multiple choice, you will have both options there. So be super careful. So if I look at my smallest angle, I need to look for my smallest side. So between these 3 numbers, 9 is the smallest. So across from that side is going to be my smallest angle. Then we go to the next number, okay? 12 is our medium or our middle. So across from it's going to be angle C. And then our largest, okay, it's going to be that 15. Go across from that. There's our largest angle, angle A. So the big little helpful tip, kind of like the rule, you could say, the biggest is across from the biggest. The smallest is across from the smallest. Doesn't matter whether you're going angle to side or side to angle. So, biggest across from biggest. Smallest across from smallest. Right. Hopefully that helped out. I'll do a little highlight, make sure it stands out.